this is what we have to do to determine the priorities, 1, 2, 3, and 4, of the groups attached to the chirality center. So I've put an example of a chirality center there with 4 different groups attached to it. The rules go, you compare atoms of each group, starting with the atom closest to the chirality center. You don't take the whole group, you just take the atom closest. In this example, we're going to take the O, the Cl, the H, and the C. Just those groups, those atoms rather, not the whole group. And the rule is higher atomic number is going to be the lower atomic number. So what do we have? Cl, O, C, and H. What's
priority?
the higher? It'll be the higher priority if it has a higher atomic number.
That's a
Okay.
better way. That's a better way.
Oh, okay.
Cl, O, C, and then H.
Cl, O, C, and H. Okay, good. 1, 2, 3, 4. And you see a lone pair is the lowest priority. So this would be higher atomic number is higher priority. Okay, we got that? Okay, so we're going to move on to system. Here we have first example A, a simple one, just like we did before, except what I'm doing now is just comparing 2 groups, so we're not dealing with all 4 at once. But this is the same idea. So you can see which of 2 groups has higher priority. So what you do is that star represents the chirality center. On A there, which is higher priority, the CH3 or the H? CH3, because carbon is higher in atomic number than H. So that works out to be the highest priority. That's number 1 and number 2 of those 2 groups. The second one, we start out at that star and we move out to a carbon right here. Both of them are carbon, so that is the same. We now have a tie. What we have to do is break the tie by what is attached to that carbon. So that carbon, and you don't go back to the first one, so you're going to have 3 groups attached to it. In the case on the left, you have a C, and another C, right? On the right, you have O, just 1 atom, and 2 H's, right? You keep it at 1 atom. Now what you have to do is compare the highest priority group on each carbon. So I lined them up there with the highest priority first. On the right there, you have the OHH. And compare 1 at a time. It's not the whole group. So if you compare C to O, which one wins? O. And so this is the highest priority group. This is number 1. This is number 2. Do you see how that works? Okay, on the next one, you see the same thing happens. You have a tie at the first position, right here. But then this one is what? Attached to that is a C, H, H. Attached to this is C, H, H. There are 2 H's attached to that carbon. So we're still tied. Then what we have to do is go out to the next carbon. So you see this one, the red one, has a C, and an H. Over here, it's a C, an H, and an H. So which wins? The right or the left? The right one, because here is where the tie is broken at this position. So this is the winner. This is number 1. And this is number 2. Okay. The next one. You want to do that one? Which one is it?
The first one.
The left or the right?
Left.
I hear different answers.
Left, yeah, because it wins on the first carbon right away. Because that first
Right.
carbon is CCH.
When you get to the first carbon, this carbon is attached to C, C, and H. This one is attached to C, H, and H.
So if the right side already lost, it's right there. So
The right side lost already, so it's this
zero
one.
oxygen.
You don't look out over the whole thing. You do it one atom at a time. Yeah? Now this last one, you're going to be following the rule that I listed on the previous slide there. That when you have a double bond, you don't have as many atoms you can identify as being part of, attached to that. So that isn't going to work. So what they do is they say both ends of a double bond are attached twice to whatever's at the other end. So, for example, this one right here, this C is going to be considered, it has one H up here. It's going to be considered attached to a C, and I do this in parentheses to remind me that that second C, it's attached twice to the C. That second C was because it was a double bond, and then it's also attached to an H. Okay? Over here, the carbon is attached to a C, and an H. They all count the same. That C in parentheses was just a note to remind me what's going on. Yeah? Did you have a question? Okay. So we're tie, and then we have to go to the next one. This carbon on the right compound is attached to 3 H's. The one on the left is attached to a C, which is the double bond again, an H and an H.
Oh,
Do you see?
yeah, okay.
So you have to say it's got to be attached to 3 things. It's attached to 2 H's and the C that was the double bond. You say, that's why I put it in parentheses. So that's to remind you that that came from the double bond.
So double bonds, I mean, you can count them backwards. So,
Yeah, you count, for a double bond, you count both ways, both ends. Uh-huh. So which one is the highest priority, the left or the right? This one. Are we getting the idea? It's because that one wins. Okay.